instantaneous acceleration. When you talk about instantaneous acceleration, it means that your acceleration first, you know that acceleration A is what? Changing velocity with respect to time. We can say change in velocity over change in time. So that means if you want instantaneous velocity, that means the did I say velocity? Sorry. If you want instantaneous acceleration, that means the acceleration measured on the instant, at a particular instant of the motion. Maybe what's the acceleration at a time equals to 1? What's the acceleration at a time equals to 6? So acceleration at a particular instant. Since acceleration on its own is what? Change in velocity over change in time. That means instantaneous acceleration, that's acceleration A of t, will be equals to what? Limit as t approaches 0 of what? Change in velocity over change in time, which still mean what? dv dt. That means you differentiate velocity with respect to time. So that means for you to find instantaneous velocity, instantaneous acceleration, your velocity must have been in the form of what? An equation or expression. So you differentiate your velocity with respect to time to get what? Acceleration. That's number one of it. But however, if you were not given velocity in form of an expression, and then instead you were given a displacement s equals to a certain equation, maybe 3t squared minus 2t plus 1. Now you know that your instantaneous velocity is what? ds dt. And now you want to find instantaneous acceleration. So that means you are now differentiating d dt of what? Of this one, of your instantaneous velocity, which is an ds dt. So that means you are differentiating the differential of what? Instantaneous velocity. And what will that result? The result will be equals to d squared s dt squared. So what this means is, if you are given a displacement, expression for displacement, and then for you to find acceleration, that means you differentiate that displacement 2 times to get the equation or the expression representing acceleration. Okay, take for instance, if the displacement given was 3t raised to the power of 3 plus 2t squared minus 1, and then you are told to find instantaneous acceleration at a time t equals to 1 second. What would you do? This is what you do. Now, you know that instantaneous acceleration equals to what? dv, that's change in v, that's differential of v with respect to t. which is still the same thing in terms of displacement, will be what? The square s dt squared. That means you differentiate displacement 2 times. Or if you have the expression for velocity, you differentiate velocity 1 time to get acceleration. But if it was displacement that you were given, you differentiate it 2 times to get acceleration. So now, given our s, let's do the double differentiation of this s. So the first one, the s dt will be equals to the power of t here will multiply with the coefficient of t. So that will be 3 times 3 times t raised to power of, the power of this t will be reduced by 1 raised to power of 3 minus 1. Plus, you come to this one, 2, the power of t here is 2 times the coefficient of t here 2. That will be 2 times 2 times t raised to power of what? 2 minus 1. And then here is a constant. The reason we call it a constant term is because it doesn't have the variable, the independent variable. The independent variable here is t. So there is no t here. So that's why we call it what? A constant. And according to principles of differentiation, one of the principles of differentiation, if you differentiate a constant term, it will give you what? 0. That will be minus 0. No matter what the constant term was, even if it is 5, 10, 11, 1 million, since it's the constant term, a term without a variable, independent variable, if you differentiate it, it will give you what? 0. So now, that means our ds dt equals to what? 3 times 3, 9. T raised to the power of what? 2. 3 minus 1, that's 2. Plus 2 times 2, 4. 4t raised to the power of 1. But there's no need writing the 1 there. Then 0. 0 is gone. So this first differentiation that I've done is the expression I have here. If I may ask you, does it represent velocity or acceleration? This expression represents what? Velocity. It represents what? Velocity. Instantaneous velocity. But what we are looking for is what? Instantaneous acceleration at what? At time t equals to 1 second. So now, for us to get acceleration now, acceleration will be what? You differentiate these 2 times. That's d square s dt square equals to d square s dt square equals to, you now differentiate the velocity. You know, as instantaneous acceleration is dv dt, and then expression for v is what? 9t squared plus 4t. So if you differentiate this one, or saying differentiate s 2 times, that's we take differential of this again. So this will be 9 times 2 times t raised to the power of what? 2 minus 1 plus 4. The power of t here is 1. 4 times 1 times t raised to the power of what? The power of t here is 1 raised to the power of 1 minus 1. So our instantaneous acceleration, which is the same thing as dv dt, which is the same thing as d square s dt square, will be equals to, so 9 times 2 is 18. 18t raised to the power of what? 2 minus 1 is 1. 18t raised to the power of 1. So, but we don't write the 1 there. plus 4 times 1, 4. T raised to the power of 4 times 1, 4 times t raised to the power of 1 minus 1. 1 minus 1 is 0. So that will be 4t raised to the power of 0. Then according to law of indices, anything raised to the power of 0 equals to 1. X raised to the power of 0 equals to 1. 3 raised to the power of 0 equals to 1. That's according to law of indices. Anything raised to the power of 0 equals to what? 1. So therefore, our instantaneous acceleration, which is dv dt, or you say the square s dt square, equals to 18t plus 4 times 1. That's t raised to the power of 0 is 1. So that our acceleration, the expression representing our acceleration, will now be what? 18t plus 4. 18t plus 4. So in that question now, we are told to find the instantaneous velocity, instantaneous acceleration at t equals to what? 1 second. So we substitute 1 in the expression representing instantaneous acceleration. So wherever we see t, we put 1. So our acceleration at time 1 second will be 18 times 1 plus 4, which equals to 18 plus 4. And 18 plus 4 is what? 22. 22 meter per second squared. Don't forget to include your units. Unit for acceleration is meter per second squared. So that is how we treat instantaneous acceleration. So let me give you something to see how well you've understood what I've done so far. Now, let me say that the displacement of the motion of a body is represented by s equals to t raised to the power of 3 plus 2t squared minus t plus 3. So let's say the displacement of the motion of a body is represented by what? S equals to t raised to the power of 3 plus 2t squared minus t plus 3, where s represents the displacement and t represents what? Time in seconds. This one displacement in meters. Then I'll ask you, find the instantaneous velocity. Find the instantaneous velocity and acceleration at time t equals to 1 second. So you pause the video and do that, and let's see what your answer will be. So if you have done that, let's do this one together and see if our answers are the same. So we have to find what? Instantaneous velocity and acceleration. So starting with that of velocity, instantaneous velocity will be equals to ds dt. So we differentiate this expression with respect to t to get velocity. So if you differentiate this will be 3 times 1 times t raised to the power of 3 minus 1, plus this one will be 2 times 2, 4. That's 2 times t raised to power what? 2 minus 1. Let me clean. Okay, let me not clean that yet. So we go to the next one, minus t. And minus t, that will be the coefficient, the power of this t here is 1. So that will be 1, and the coefficient of this t here is what? Minus 1. The coefficient of this t here is what? Minus 1. There's an invisible 1 there. Whenever you see a variable and there's no number written before it, that means by default, the coefficient of that variable is what? 1. And here there's minus here, so it's minus 1. So here will be minus 1 times 1 times t raised to the power of just permit me to clean here. Okay, let me clean that. So t raised to the power of what? 1 minus 1. And here, as you remember, if you differentiate a constant, it will give you 0 plus 0. So this will be equals to 3t raised to the power of 2 plus 4t raised to the power of 1, then minus t raised to the power of 0. And this equals to what? 3t raised to the power of 2 plus 4t. Anything raised to the power of 0 is 1 minus 1. So now we've gotten an expression for our instantaneous velocity. So what is now left is for us to substitute. Now left is for us to substitute. So now our velocity at time t equals to 1 will be what? 3 times 1 raised to the power of 2 plus 4 times 1 minus 1, which equals to 1 times 1 is 1 times 3 plus 4 minus 1. 3 plus 4 is 7 minus 1 is 6. 6 meter per second. Then for acceleration, our acceleration means we have to differentiate velocity with respect to time. And the expression for our velocity is what? 3t squared plus 4t plus 4t minus 1. So if we differentiate, this is the expression for our velocity. So if we differentiate that, the coefficient here 2 times 3 will be 6. 6t raised to the power of 1. You differentiate this one, that will be plus 4. Then if you differentiate the constant term here to be 0, so we don't include it again. So now we've gotten an expression for acceleration, which equals to what? 6t plus 4. So now our acceleration at time t equals to our acceleration at time t equals to 1 will be what? 6 times 1 plus 4, which equals to 6 plus 4, which equals to 10 meter per second squared. So therefore, our instantaneous velocity equals to 6 meter per second, while our instantaneous acceleration is what? Our instantaneous acceleration is 10 meter per second squared. So if you need more examples or more questions with respect to instantaneous speed or velocity, or you need more questions with respect to uniform motion as a whole, you can follow the link on the description below. Join our WhatsApp group. So in that our WhatsApp group, we make available to you questions on particular topics of interest. Give you a collection of questions, and then also help you to solve some of them or answer some of them and post. So thank you.